What if I told you the most important secrets of our solar system aren't found on Earth, Mars, or even the Sun, but hidden in a frozen realm so far away that sunlight barely reaches it? And what lies there could rewrite everything we think we know? Join us on an exploratory journey to the very edge of our cosmic neighborhood, where ancient ice worlds hold the keys to our origins. Imagine standing at the edge of everything you've ever known, on the last solid piece of ground before the world dissolves into fog. Now imagine taking one step farther. Into a place no human eye has ever seen clearly, a place so distant and untouched that it feels less like a region of space and more like a memory the universe has been trying to forget. This is the Kuiper Belt. And if our solar system were a book, the Kuiper Belt would be the hidden chapter ripped out long ago, yet somehow still lingering between the pages, waiting for someone brave enough to look for it. We often comfort ourselves with the illusion that we understand the solar system. After all, we memorized the planets in grade school. We saw pictures of Mars. We know Jupiter is big, Saturn has rings, Neptune is blue. But that sense of familiarity is a lie. Because everything we think we know is just the warm, well-lit interior of a house. And the Kuiper Belt? That's the vast, frozen wilderness outside the door, a wilderness so ancient and so undisturbed that it may hold the very first ingredients of everything that exists today. This region, stretching tens of billions of miles beyond Neptune, is not just a collection of rocks and ice. It is a cosmic vault. A time capsule sealed since the birth of the solar system. When astronomers study objects in the Kuiper Belt, they're not just looking at distant debris floating in the dark. They're looking directly into the past, into the raw, untouched materials that once collided, merged, and ignited to become the planets, including Earth itself. In other words, when we peer into the Kuiper Belt, we are staring at the unedited blueprint of our own origin story. And yet, for all its scientific value, the Kuiper Belt has an emotional gravity of its own. There is something humbling, almost haunting, about the idea that billions of untouched worlds have been drifting in silence for 4.5 billion years, never warmed by sunlight, never molded by storms, never visited by life. Pluto, the most famous resident of this distant frontier, is only one among thousands, tiny frozen worlds, each with its own secrets. Some elongated like meteors, others perfectly round, others spinning so fast they flatten like pancakes. These worlds do not behave the way planets should. They defy order. They break rules. They remind us that the universe doesn't exist to fit our expectations. The Kuiper Belt is distinct from the even more distant Oort cloud, which is a spherical shell of icy objects much further out. Unlike the Oort cloud, which is thought to be a reservoir for long-period comets, the Kuiper Belt is a flattened disk, a direct remnant of the protoplanetary disk from which our solar system formed. Its objects, known as Kuiper Belt objects, KBOs, or trans-Neptunian objects, TNOs, are essentially primordial building blocks, preserved in a deep freeze. The sheer scale of this region is staggering. If Earth were the size of a single house, the Kuiper Belt would be the size of an entire city stretching beyond the horizon, alien, unexplored, and overwhelmingly vast. The truth is, we haven't just ignored this outer frontier. We've barely acknowledged its existence. Only one spacecraft, New Horizons, has ever reached it, and even then, it captured just the briefest glimpse before continuing into the void. This makes every piece of data we gather from this region incredibly precious, a tiny window into an immense unknown. So the question is, why does this place matter? Why should we care about a frozen band of ancient rubble drifting beyond Neptune? Because the Kuiper Belt is the closest thing we have to a cosmic birthplace, a place where the whispers of creation are still echoing. And to understand who we are, we sometimes have to journey back to where everything began. It's a testament to the enduring mysteries that lie just beyond our current reach, inviting us to push the boundaries of exploration. If you're fascinated by these mysteries and want to join this journey through the forgotten edges of our solar system, don't forget to subscribe. Your support gives this channel the fuel to continue traveling deeper into the unknown, bringing back the stories the universe has kept hidden for billions of years. Now, a question for you, something to reflect on. If you could choose only one truth to uncover from the Kuiper Belt, which would it be? A. The origins of Earth and how life began. B. The discovery of entirely new worlds unlike anything we've ever imagined. Comment A or B below. I'm excited to see which mystery pulls you more strongly toward the edge of the solar system. The deeper we move into the Kuiper Belt, the more the familiar logic of the inner solar system begins to unravel. Out here, the rules bend. Orbits tilt. Worlds behave in ways that challenge everything we thought we understood about planetary formation. This region is not merely a boundary, it is a laboratory shaped by chaos, gravity, and time itself, a place where nature seems to experiment with ideas it never used anywhere else. And the closer we look, the more the Kuiper Belt reveals itself as a realm of relationships, interactions, and gravitational dances that feel almost poetic in their strangeness. One of the most striking revelations is the existence of binary systems, pairs of worlds locked together in a gravitational embrace, orbiting each other like ancient celestial partners. Pluto and Charon are the most famous example, a true binary dwarf planet system, but they are far from the only one. Across the Kuiper Belt, countless pairs drift together in the cold, each one a reminder that even in the loneliest reaches of space, companionship emerges. These systems hold extraordinary scientific value. By studying how they orbit, how they balance, how they transfer momentum, we learn not just about distant ice, but about ourselves. They tell us that formation is rarely solitary, that worlds are shaped through interaction, tension, cooperation, and collision. And somehow, that truth feels deeply human. The formation of these binaries, especially those with nearly equal masses, suggests a gentle accretion process in the early solar nebula. Instead of violent impacts, these pairs likely formed when two objects slowly spiraled into each other, or captured one another, in a low-velocity environment. This contrasts sharply with the more energetic collisions thought to have shaped the inner planets, offering a unique window into different modes of planetary construction. But binary systems are only the beginning. The structure of the Kuiper Belt itself is far more distorted than once believed. Rather than forming a neat, flat disk like the orbits of the major planets, the Kuiper Belt appears warped, twisted, and stretched. Some objects drift in wildly tilted paths, others follow elongated routes that seem to defy the gravitational influence of the known planets. Neptune sculpts part of this chaos with its powerful gravity, tugging and reshaping orbits over billions of years. Yet even Neptune's influence cannot fully explain the patterns astronomers observe. There are alignments too precise, clusters too unlikely, tilts too extreme. It's as though something unseen has been brushing its fingers across the solar system, leaving subtle trails behind. And this mystery reaches us more personally than we might expect. Because these strange orbits aren't just mathematical curiosities, they are clues, breadcrumbs leading us toward understanding a hidden architecture of the solar system. They whisper of forces we have not yet mapped, perhaps of planets we have not yet found. They challenge us to question what we assume is complete. The anomalous clustering of the most distant KBOs, for instance, points to a gravitational perturber, a massive, unseen body influencing their paths. Amid this gravitational puzzle, the Kuiper Belt also reveals its role as the cradle of many long-period comets. These icy travelers, with their glowing tails sweeping across Earth's skies, may trace their origins back to these distant worlds. Some scientists believe that comets from regions like the Kuiper Belt might have delivered water to the early Earth, seeding the young planet with the foundation for oceans and, eventually, life. This idea gives the Kuiper Belt a new dimension, no longer just an archive of cosmic history, but a potential contributor to our own existence. To think that fragments of these icy bodies could have shaped the fate of Earth is both humbling and exhilarating. We would know far less about this region were it not for one daring visitor, NASA's New Horizons spacecraft. In 2015, it offered humanity its first up-close look at Pluto, revealing a world far more alive and complex than anyone expected. Pluto's active geology, its nitrogen glaciers, and its complex atmosphere shattered preconceived notions of what a dwarf planet at the solar system's edge could be. It was a vibrant, dynamic world, not merely a frozen rock. But the real moment of revelation came later, when New Horizons continued deeper into the Kuiper Belt and flew past Arrokoth in 2019. That encounter was a quiet revolution. Arrokoth, with its untouched, pristine shape, showed us how the earliest building blocks of planets gently merged, not through violent collisions, but through slow, delicate unions. This bilobed object, resembling two pancakes gently pressed together, is a relic from the very dawn of the solar system, preserved in its original state. It was as if the universe had preserved one perfect example of its original craftsmanship, allowing us to witness creation frozen in time. Every discovery in the Kuiper Belt reshapes our understanding of the solar system. But more importantly, it reshapes our understanding of ourselves, our past, our future, and our place in a universe that is far more intricate than we ever imagined. The chemical composition of KBOs, rich in complex organic molecules, further fuels speculation about the raw ingredients for life being widespread throughout the cosmos. As we push farther into the Kuiper Belt, beyond the familiar worlds, beyond even the rare encounters of New Horizons, we enter a region that feels less like a place and more like an unanswered question. It is a vastness defined not by what we know, but by what remains hidden. The objects we have discovered so far are just the faintest hints of what lies beyond. In truth, the Kuiper Belt is only the threshold. Beyond it stretches a frontier that may contain tens of thousands of worlds still waiting to be seen, each one quietly orbiting in the cold, carrying billions of years of cosmic memory. What makes this especially profound is the realization that our maps are incomplete. Our understanding of the solar system is incomplete. And yet, even with such limited knowledge, astronomers can already sense the presence of something extraordinary in the darkness, patterns in the motion of distant bodies, subtle alignments that should not exist if the solar system were exactly as we currently imagine it. These gravitational signatures hint at worlds we cannot yet see, worlds large enough to influence the orbits of objects thousands of miles away but distant enough to remain hidden from our most powerful telescopes. It is as though a curtain has been drawn across the outer solar system, and only the faintest shadows leak through. Among these shadows is the possibility of Planet 9, a hypothetical giant world far beyond Neptune, perhaps 10 times the mass of Earth, orbiting so distantly that a single year there might last 10,000 of hours. Its existence is not yet confirmed, but its influence seems to echo through the Kuiper Belt like a quiet pulse. The clustering of the most distant KBOs, whose orbits are strangely aligned, is the primary evidence for its existence. Without Planet 9, these alignments are statistically improbable, suggesting a massive gravitational shepherd. If Planet 9 is real, then it represents more than a new world. It represents a shift in perspective, a reminder that our cosmic neighborhood still contains mysteries grand enough to reshape everything we thought we knew. To discover such a planet in our own era would be equivalent to what Pluto was in 1930, a revelation that expands the horizon of human imagination and invites a new generation to look upward. The search for Planet 9 is an active and thrilling frontier in planetary science, pushing the limits of observational astronomy. But the mystery of Planet 9 is only one thread in a much larger tapestry. The Kuiper Belt challenges us not simply because of its physical distance, but because of what it symbolizes, the humility required to accept that our knowledge is always incomplete. For centuries, humanity believed the solar system contained only 6 planets. Then 7. Then 8. Then 9. Then back to 8, with countless dwarf planets recognized later. Each time, the boundary of understanding shifted. Each discovery forced us to revise our place in the cosmic hierarchy. And now, standing on the edge of the Kuiper Belt, we confront the possibility that the solar system is larger, stranger, and more populated than we ever dared to imagine. There is something deeply human in this unfolding mystery. It reminds us that exploration is not a finished story. It is a living one. Every new observation, every small icy world catalogued, every unexpected orbit mapped, these are the quiet beginnings of the next chapter. Future missions, perhaps dedicated KBO orbiters or even sample return missions, could revolutionize our understanding. Next-generation telescopes, both ground-based and space-based, will continue to push the boundaries of detection, revealing more of the Kuiper Belt's hidden population. One day, a spacecraft far more advanced than New Horizons may journey through the Kuiper Belt and catalog hundreds of worlds in a single mission. One day, the blueprints for such a craft may sit on a desk in a laboratory, drawn by someone inspired by the very questions we are asking now. The technological challenges are immense, but the scientific rewards are even greater, promising to unlock secrets about the solar system's formation and evolution that are currently beyond our grasp. And beyond scientific value, the Kuiper Belt offers a lesson in perspective. It teaches us that our search for answers is also a search for humility. That the universe rewards curiosity but punishes certainty. That the most meaningful discoveries are often the ones we never expected to find. Perhaps that is why the Kuiper Belt feels so magnetic, not because of what we know, but because of how much is still concealed within the silent dark. As you reach the end of this journey through the outer frontier, remember this: the solar system does not end where our imagination fades. In many ways, it is only beginning. In the end, the Kuiper Belt is far more than a distant ring of ice, it's a mirror reflecting our deepest human truths. Every discovery there reminds us that the universe is built not on certainty, but on wonder. That even the coldest, darkest corners of space can illuminate who we are and where we came from. The untouched worlds drifting in silence for billions of years teach us patience. The strange orbits teach us humility. And the possibility of unseen planets teaches us that life will always hold mysteries waiting for those brave enough to seek them. If this journey has inspired you, if it has sparked curiosity or wonder, then I invite you to subscribe. Join our community of cosmic explorers, hit that notification bell, and share your thoughts in the comments below. Your engagement fuels our mission to continue exploring, questioning, and bringing you stories from the very edge of the cosmic horizon. Let's uncover the universe's secrets together.